And I'm going to share my screen. Take a start. Okay, so my name's Helen Sandison. I'm a senior engineer at CENSIS. CENSIS is the Innovation Centre for Sensing, Imaging and IoT. And we're based in Glasgow, just off George Square. So I'm part of the technical team. We're quite a small team, just a group of 6, and we work on different aspects of sensor systems, whether it's the hardware or the software, data analysis, or sort of comms or networking. We kind of covered a lot. Joining us, 1 second. So things we're going to be talking about today, we're going to start talking about first, just think about the human senses. There are our own sensor devices, if you like. And then what is a sensor device? What needs measuring? How does a sensor work? Talk about sensors in daily life. Sensors in your mobile phone. Hopefully get a demo or 2 going there. Internet of Things. Somebody mentioned IoT. A little bit about that. What's a typical day for a sensor engineer? A bit about the kind of projects I work on, and then at the end, just some tips for women working in technology. So human senses, of course, these are our sensor devices. We use them kind of as input devices to gather information. And our body converts the data they gather into sort of chemical and electrical signals, which are processed by the brain. And they connect you to the environment. They help you to understand the environment around you, help you to learn and make more informed decisions. If you're in danger, if you get a car horn beeping at you, you may have to jump out of the way. A bitter taste can potentially alert you to some potentially poisonous or harmful foods, for example. I just wanted to go a little bit into the human senses to start with. As I was doing some research into this talk, I found some interesting data and info I thought I would share. So everyone has a different number of taste buds, be anywhere between 2,000 and 10,000. And of those, we can distinguish about 100,000 different flavors, even though there are only really 5 basic tastes: or sweet, sour, salty, bitter, and umami. In case anyone is joining us. Okay, so that's taste. Moving on to hearing. Again, just thinking about data input. So we can hear sound waves down as low as 20 hertz, as high as 20,000 hertz. Or at least you can when you're younger. Of course, your hearing drops off as you get older, particularly in the higher frequencies. And the human ear can hear both very quiet sounds, very low intensity sounds, and extremely loud sounds. And the human ear can actually adjust its sensitivity to increasing sound levels to be able to protect it to some degree. So the graph at the bottom shows the human auditory field, again between 20 and 20,000 hertz. Of course, there's infrasound. Elephants, for example, can hear much lower sounds than we can. And then ultrasound, so cats and dogs can hear up to about 40,000 hertz. Bats and dolphins can hear, looks like all the way up to 160,000 hertz. And of course, the noise levels, so that's a decibel chart. We can hear very low noises down, whispering, rustling leaves, and that's about 30 dB, 30 decibels. We can go all the way up to rock concerts and airplanes taking off, which is at the higher level. And of course, anything above about 85 decibels can potentially be harmful. Anything above 120 decibels can be extremely harmful permanently to the ears. And the important thing about the decibel is, of course, it's a logarithmic chart. So each step of 10 is actually 100 times more intense than the previous. So that's a huge dynamic range that the ears can detect. And finally, just a bit about sight. So your eyes can distinguish approximately 10 million different colours. The human eye can detect wavelengths between about 380 to 700 nanometers. If the human eye was a digital camera, it would have 576 megapixels, which is kind of extraordinary. You think a mobile phone typically has maybe 12 megapixels, maybe 14. I think the latest iPhone might have a 48 megapixel camera in it. But yeah, that's a huge amount of information that the eye and the brain can process. And there's just an example of the visible region of the electromagnetic spectrum at the bottom there, between 380 nanometers and 700 nanometers. Just to give an idea of the size of that, thickness of a soap bubble membrane is just around about 500 nanometers. And of course, I'm sure you know the visible region is a very small part of the electromagnetic spectrum. Below visible light, or with a lower wavelength, we have ultraviolet, and of course infrared, where you get thermal images, is a higher wavelength of red. So I really just wanted to introduce that to start thinking about our human senses in terms of their input and the information they gather, in terms of the range and sensitivity, resolution, what they can sense, but also what they cannot sense as well. So that in mind, what exactly is a sensor device? Probably most simple explanation is it's a device that detects and responds to some type of input from the physical environment. And we have a few examples here. That's a temperature sensor right at the top. And that's a photodiode, a light sensor to the right. It's a pressure sensor connected to a little red electronic processing board in the middle, and a small camera, probably a mobile phone camera at the bottom. So think about sensor devices and robots. Sometimes they have to mimic the human senses. So cameras will mimic the eyes, microphones can mimic the ears. Tactile sensors down at the bottom will mimic touch. And also temperature and pressure sensors to some degree can mimic touch. And of course, it has other ones as well to help to orient itself and to be able to move around. And some of the things that need measuring, so position, good to know where you are in the world sometimes. Using GPS is an object where it needs to be, perhaps in a factory situation. Is it something level if you're building things? All of these require position center find. Speed, of course. Did something move? How fast is it moving? Is it accelerating? Is it going too fast in the case of a radar gun? Light, how bright are my surroundings? Is the camera adjusted to the proper light levels? How does my car lights automatically switch on? These would all require an ambient light sensor of some kind. Temperature, of course, is my car engine overheating? Do I have a fever? Am I ready to put food in it? All of these require a temperature sensor. So quick demo of a temperature sensor. Can you see my screen okay?
Yep.
So what I've got here is, if you can see that, so that's a temperature sensor here, and it's connected by this jumble of wires to an Arduino. I guess you're both familiar with Arduino. It's quite similar to a Raspberry Pi. Of course, sensor prototype projects often start off looking a bit like this, a bit messy. But I just wanted to demonstrate using the serial link. So that temperature sensor is working at the moment. It says it's about 21 Celsius room temperature. So I can put my finger just on the sensor device and you should see it immediately start to rise. 26, 27. That's just a very cheap, that costs about, I think it's £4, that sensor. Arduino is also, I think, about 30, 40 pounds. So it's quite a low cost device to get started with. I take my finger off the sensor and then the temperature slowly drops back down again to 24 Celsius. Basic demo, but just to kind of get us started thinking about sensors. Go back to this is something I did earlier today. I just basically did the same experiment. So yeah, temperature started off being about 21 Celsius. and that's Celsius up and down the y-axis, of course. Touch the sensor, you can immediately see the temperature rise. Release the temperature sensor, you can see it slowly start to drop back down to room temperature. And then I touched it again and you can see it rise again. And even though that's kind of a really, really simple demo, I think it kind of explains in some ways what is a sensor system, and this can be applied to pretty much any sensor system that you can find or you can come across. And I've got the main kind of elements of a sensor system to the left, so I just wanted to go through them. So sensor itself is where you start. That's the device that detects and measures change of some sort, in this case temperature change. The processor, well, that's the brain of the sensor. It processes the data. It might package up the data and begin to send it to wherever it needs to go next. The communications, so it could be a USB cable, it could be Wi-Fi, it could be a phone signal. That's how you get the data from the sensor device to the destination. Data needs to be stored, managed, and organized in some way. Sometimes that can be, of course, in the cloud. And once you've got your data, you may want to convert it into some kind of meaningful information. Maybe put it in a visual format, a graph, to easily interpret results, and then you can act on that result. So essentially, using those different elements, you go from the raw data through to kind of useful information that you can act on. And it tends to be the sensor, the processor, and the comms is at the device level or hardware. The data, the analysis, and the interpretation tends to be at the application or the software level. I think, as I said, pretty much any application area, the principle remains the same. You need to sense something, measure it, communicate it somehow, process that information, and then eventually perhaps you want to act upon that information. Of course, in the home, whether we know it or not, we're surrounded by all kinds of different sensors. Of course, thermostat, central aircon, perhaps you have lights and curtain sensors, of course, smart appliances, background music, etc. In the car is stacked full of sensors, radar sensor at the front or the back to help with parking. You've got your GPS for your sat nav. You may have a dash cam. You probably have the aircon, fuel sensor, of course, exhaust gas sensor, and many more. And increasingly in daily life, whether we know it or not, and perhaps intrusively, so more and more sensors are being surrounded. We're being surrounded by more and more sensors. Supermarket, or bottom left is airport security. That's biometric passport check, and that's a thermal imaging to check people's body temperature. In fact, sensors are everywhere. This is a schematic that we have on the CENSIS website. And this covers a lot of the application areas and markets that we do projects in. You can probably see it covers a really huge wide range. Everything from transport, hospitals and healthcare, smart cities, air quality, food and drink, tourism, fish farming, oil and gas, you name it. Sensors really are everywhere. So I thought it was interesting to look at some of the sensors in our mobile phone, in case you've ever wondered how a mobile phone knows how to flip a photo around when you rotate it, for example, or if you're doing a game and you want to change direction, what is actually going on in the mobile phone to be able to act on that. Of course, like a car or a home, the mobile phones are completely stacked full of sensors. But it's proximity sensor to detect how close the phone is to your ear when you're making a call, or image sensor. Of course, cameras. There's usually at least 2 or 3 cameras, I think, in phones these days. Accelerometer and gyroscope, that helps to be able to orient and understand the rotation of the phone. Of course, microphones, fingerprint sensors, many more besides. So if you like, I did send that out in the email, in case you want to download that app. It's it's an app that accesses many of the sensors in the mobile phone, and I wanted to perhaps run a few. If you give me a second. My phone onto the screen. Did you download the apps, by the way?
Yeah, I've got it installed just now.
So just bringing it up on my phone. So I'd start with the light sensor. Well, first, as you can see, there's lots of different sensors. If you've had time to have a quick look through this, then you can see there's many sensors that this can access, and you can get the raw data of the sensor. Example, for the light sensor, so there's usually an ambient light sensor. See at the front of the phone here. Press play, so it starts to gather the light data. Which in the room is fairly dark at the moment, so it's quite a low lux. But of course, if I point it towards the window, then you can see that jump up quite significantly. Put it back down on the desk, you can see that drop away again. Got a flashlight, which I can bring across the light sensor, so that gives a much higher lux measurement, up to, what's that, 2000 or so. Again, the other one I wanted to look at was the acceleration. So you've got an X, Y, Z accelerometer in the phone, and as you move the phone, rotate it in different directions, you can see that quite clearly, I think, from the X, Y, and Z axis. And that using the accelerometer, that's one of the ways that the phone can sort of orient, for example, to flip the photos. Yeah, the other one I wanted to look at was the GPS. And that takes a few seconds, I think, just to find itself. Were you aware of this app, or did you have anything similar before in the mobile phone?
Good fun with it.
Sorry?
I wasn't aware of it, but I'm having good fun with it.
Yes, yeah, I found it quite interesting to play around with. Right, so hopefully, yeah, you can see that. So the latitude takes a little while to settle, but it's 55.86 degrees. Longitude is about -4.2. So yeah, I guess that's reasonably accurate. Seems that I'm about 31 meters higher than sea level. So there's loads of examples there to play around with. There's actually lots of really nice experiments. If you just want to Google Google the 5-box experiments, then yeah, then there's lots of examples there. Really interesting experiments, physics experiments. Have you, right, I'm just gonna come away from that. Jump back in here. So I downloaded this app just like a couple of weeks ago, and I was playing around with it. I was actually on a flight to Paris, and for the last 15 minutes or so of the flight, I thought I'd switch on this app just to see if I could get any data. And I was a bit surprised at first because I could get the GPS latitude and longitude and the speed. However, the GPS, I realized, although you're receiving data, your mobile phone, you're not actually transmitting data. So I did have my phone in flight mode, but it seems that you still get your GPS. So in fact, I just recorded it for about 15 minutes in the final approach. And then I was able to plot the latitude and longitude on a map, as you can see here. I also got the altitude. So you can see actually we're in a couple of folding patterns around about 3,000 meters, followed by another one at 1,500 meters before coming down to land. And you can see the speed as well. And yeah, really quite accurate and quite interesting to be able to measure that. Right, so Internet of Things. So a couple of you mentioned, I think you're involved in IoT. I'm afraid I won't be going into a great much detail, just really to say that smartphones, wearables, sensors, they all become part of the Internet of Things as long as they're connected and sharing data. And of course, that's the basis of what makes them smart sensors as well. This is probably about as technical as we're going to get in this talk, but I just wanted to show this graph. It's about wireless technologies. So on the bottom axis, we've got data rate, which goes from low to high. In the y-axis, we've got the range, again, from low to high. So I guess we're all fairly familiar with Wi-Fi and 3G, 4G, 5G. So that has very high data rates, or can have very high data rates over Wi-Fi is quite a low range. Of course, cellular is quite a high range. If we look at the bottom left, you've got RFID, and that's your little card that can beep you into a door, for example. Near field range as well. Zigbee. Have you heard of Zigbee or LP1? Those are kind of specific IoT wireless protocols. Tends to be kind of lower data rate in terms of Zigbee, whereas LP1 is low data rate but over a high range. For example, you may want a sensor to be able to transmit its 1 point of data every 15 minutes over a number of kilometers. So we use quite a lot of LoRaWAN, LP1, Sigfox here at CENSIS for technology development. I was going to do a demo here, but I was having a little bit of trouble with it earlier, so I'm going to skip over that. But if you are interested, I'd be happy to share it at a later date. Just a little bit about a typical day for a sensor engineer. People think it's programming all the time, but of course there's a wide range of things we do. We do a lot of collaboration, meet people, companies across Scotland and beyond who are trying to solve a problem. We try to use our skills and experience across sensing and IoT and imaging to help create a solution. And of course, problem solving, find solutions to some difficult problems. Gives you a chance to really dive deep and create something new using the technology. Continuous learning, you need to have up-to-date technical knowledge, whether it's the latest bits and bobs that you can see down the bottom left, bits of electronics or so on. Constantly need to learn programming languages and really continuously develop your skills and abilities. Of course, design and creation, you need to understand customer requirements carefully. You need attention to detail, you need to be able to think through a problem. Communication and interpersonal skills, positivity and integrity is a good skill to have. If you made a mistake or you don't understand something, it's good to put your hand up and say so quickly. The problem will get fixed. And of course, you get to go on field trips and travel. You may want to go initially and gather some data and understand about the environment that you might be working in. It could be something outdoors, as we see here. It could be in a factory. You get to test out your new creation in its kind of real life environment. And occasionally you get to present your work and learn about new technologies and applications at conferences. And of course, computing science skills are integral to engineering, but not only. There are all these others as well. A couple of examples of sensors I've used and projects I've been involved with. And oh, didn't want to see that. I might come back to that in a second. Go over to this one. So this is a face mask detector. This is a project I did with some University of Glasgow computing science students a couple of years back. This is during COVID lockdown, and we wanted to be able to use low-cost technology to be able to create something which was useful for health and safety in the workplace potentially. So So yeah, thanks to Rory for sending me that video. So you could see what's going on there. So as well as detecting a face mask using just a low-cost camera, we also had a thermal imaging module, which was kind of trained to look on the forehead and take a measurement there. And so they used machine learning techniques using TensorFlow, and they used the Jetson Nano a GPU device for the real-time machine learning. So that's really interesting project to get involved in. Tips for women in tech. Well, I think being curious is the main thing. If you're curious or passionate about something, you will always find your way. Find your allies, I think is also a good one. Find a group who are interested in the same topics as you are, and know that you belong in the tech world. Accept all praise, show off your accomplishments. Do ask for feedback and take any criticism as a positive thing. The really important one is never stop asking questions. There's no such thing as a stupid question. Some groups and community organisations I wanted to highlight. So Ada Scotland, of course. Thanks for inviting me to do this talk. Ladies of Code, that's an international community of professional women developers. Girl Geeks supports females in STEM through connections, opportunities and mentoring. Equate Scotland is another professional women organisation for support in science, engineering, tech and construction. And of course, the STEMettes work to inspire, support and motivate girls, young women and non-binary people aged 5 to 25 years in STEM subjects. What I wanted to highlight, so Code Bar, they facilitate the growth of diverse tech community. They run free regular programming workshops for minority groups in tech. Coder Dojo is a free coding club for young people. Code First Girls, again, inspiring women to become developers and future tech leaders. And Code Your Future is a group that work with refugees and disadvantaged people to learn some code. So this might be more interesting for you. If you go to the CENSIS website, we've done some guides to get started with both IoT and also cybersecurity, of course, which I haven't mentioned at all during this talk, and also computer vision as well, so using cameras and machine learning projects. If you're interested, you can use that QR code, which should take you directly there. Yeah, that's my final message. Let's help create a more equal, welcoming and diverse tech community. We all use technology, but we should all be involved in creating the technology as well. Thanks for joining. Does anyone have any questions?
How did you get into, like, what's the background? Did you like physics or?
Yes, I initially studied physics and astronomy at Glasgow. I continued studying physics. After that, I went to a defence company and I worked on radar technology for a number of years. But then I kind of made my way through different sensor aspects in engineering, whether it was photonics or geophysics or microelectronics, and that was prior to coming to CENSIS. So kind of more by accident than design, but my career has been increasingly in different types of sensor technology. And at the moment, it's very varied, the work I do. So yeah. Any more questions or comments?
Yeah, I've got one more
Mm-hmm.
about CENSIS. So do you like help companies that need like IoT or sensor department, or is your job more educational?
It's a bit of both, mainly actually involved with industry. The kind of core of what we do is to bring ideas in academia and research into industry. So we do a lot of collaborative work between universities throughout Scotland and companies within Scotland and beyond Scotland as well, throughout the UK. But there's many different aspects to our work. We can do consultancy work. We can support PhD programs in sensing. We can, yeah, as I said, do collaborations between different companies, small companies, medium companies, large companies. It's really a wide range of things that we do. I'm happy to discuss if there's anything else that you'd like to discuss. My email is there. That's the CENSIS website, and that's our Twitter. Follow, then go ahead. Any more questions before we wrap up this afternoon?
Yeah, sorry. I just wanted to know what the project or demonstration you were going to give in the IoT plug and play was.
Yes, so that was I was going to use Microsoft Azure. It's called IoT Central. Here, actually, I just share my screen again. It's called Azure IoT Central. Possibly can give a quick demo. Set up. Just give me 1 second. So use the IoT plug and play app to connect your phone. Yeah, unfortunately, it's not working very well at the moment. You can basically connect your phone, or you can connect a number of phones to the IoT Central dashboard here. It can take data off your phone and display it, such as acceleration, altitude, location, rotation, etc. And you can look at different phone data, and then you can also send commands back to your phone. So I thought it was quite a nice demo when it works to kind of demonstrate that a very basic IoT application. For someone who's not seen IoT before, then that would help them perhaps to understand. So it works, but yeah, unfortunately, it's not working very well. The dangers of doing a tech demos during talk.
Yeah, it never goes well.
No, exactly. Have you used Azure yourself?
Yeah, I've done some sort of cloud automated password crackers, things like that. Not in the kind of sensor area though.
Well, like I said, if there's anything I can help with or anything you want to follow up on, do get in touch. I recognise that certainly for a couple of you, then not much new there, but thanks for joining and sticking around anyway. And if there's no more questions, then have a good evening.
Thank you.
Thanks very much.
Thanks.